So hello everyone, I'm Jino and I will be explaining my project on multi-class classification. This is to build and train a fully connected neural network for multi-class classification using the MNIST dataset. So I'll be going through the code. So first I imported the TensorFlow is for building and training the neural network. Then I imported the MNIST dataset. Then the sequential helps me to build the network layer by layer, and the dense is a fully connected layer, and flatten turns the images into a single line of numbers. So I also used a function called toCategorical, which is used to convert the label into a format that network can use. Finally, I import the matplotlib to show images numpy for calculations and confusion matrix. So for the next part, I loaded and prepared the data. I split it into a training and test sets. I divide the pixel by value by 255 to make them into zeros and ones. Then I change the labels into one chord format so the network can classify them properly. For the to see the data, I plot the first 10 training images in a 2 by 5 grid. Each image is in a grayscale and the label is shown above it. I also remove the access to make the images clearer. So after that, I build a neural network using sequential. So for the first, I added flatten to turn each images into a 1D array. Then I added a dense layer with 128 neurons and a ReLU activation to learn its patterns. So another dense layer with 64 networks and a ReLU help that network learn more complex features. So for the final, the output layer has 10 neurons with a softmax activation. So given the probability of for each digit from 0 to 9. So then I compile the model. I use the Adam optimizer to update the weights categorical as a logs function to check errors. So this is how the metrics accuracies. Then for the I trained the model for 10 epochs with a batch size of 32. And during the training, the network improved its weights to get better at the predicting digits. So after training, I tested the models on the test data. It gave me the loss and accuracy. The model was able to correct classify more digits, which means it learned well. So next I made the prediction on the test set. The model gave probabilities for each digit and I picked the digit with the highest probability as the prediction. So finally I looked at the misclassified images. These are the images where the model predicted the wrong digit. I plot the first 10 misclassed images in a 2 by 5 grid, showing the true and the predator label in red, so it's easy to see the mistake. So, in short, this project shows a simple neural network can classify and digits accurately. So, thank you.